Good evening, my name is Frederick Hughes, and I'll be doing my presentation on project-based learning unit for ELM 200, instructor Katie Seal. My project-based learning unit would be on freshwater versus saltwater density challenge. This challenge consists of testing the density of saltwater versus freshwater, and what the students would do would measure in cups, salt, and water. 2 glasses would fill the glasses up with water, one fresh, both with fresh water, and eventually one of the glasses would add salt to it. And with adding the salt, the density level changes, which makes the objects that go into the water able to float. Where the water, freshwater, if the items were going to like the freshwater glass, they would sink because the density is different. So the students are basically learning the density changes when you add the salt. The questions I'm going to be answering as far as introduction to project-based learning unit, level for 6th grade, subject will be science, and why is it engaging for the students? Well, honestly, this kind of project, basically, it's hands-on, it's visual, it taps into them analyzing, evaluating, and creating, as well as understanding and remembering. So when you remember the steps, you understand the steps, you apply what you understand, you're analyzing it. If you need to add more salt, less salt, sometimes you have to start over, pour it out and start again. Evaluating if it's good enough, and if so, can you explain it to your classmates or to your teacher in the presentation? And then you create it easily because you understand what you did. Question number 2, how to use PBL to increase cognition, and how does PBL challenge students? Well, they will apply what they've learned, problem solve, collaborate between each other, the other students, as well as with the teacher for open communication and feedback. Use problem solving skills and collaboration. That means communication between themselves, positive communication, the kind of communication where it's not just one person dictating, it's more of a collaboration as far as taking it in, more ideas the better. And then, of course, when you understand the process of the density and the excitement of one object floating and the other object maybe sinking, that allows the students to have open engagement, which is also positive. 3rd question, include levels of Bloom's taxonomy, PBL specific levels as they are working in the PBL. Or basically the blooms that are being used, I would say would be all of them, because of the fact that they're remembering the steps, maybe constantly doing it a couple different times as far as adding salt, maybe not adding enough salt, doing it again, understanding what they're doing because it's a fun project, applying what they've learned from the instructions, analyzing it, seeing if it's enough, if it's working, and if it's not working, communicating that with their teammates, evaluating, hey, it's working, we like it, look, it's floating, or it's not floating, we need to add more salt, and then at last creating what they've what they've accomplished, being able to do it again, explain it themselves, put in their own words, and show the class. The fourth and final question, justify what are the students learning once project is complete. Well, problem solving, analyzation, how much salt, how little salt, can we start over, why it worked, why it did not work, getting their brain muscles working, applying different strategies, listening to others, open communication, using different objects to see if it floats, maybe pressing the matter, maybe using golf balls instead of action figures, erasers, different things of different heavy densities, maybe even going from a glass to a bigger object of holding liquid, evaluating it, see if it works, and explaining it to maybe analyze how I can make it work if it didn't work, and understanding what they did, the accomplishments of the science project, of the density challenge. That's it. Thank you.